Hello everyone, myself Hans. Today we are going to solve the given problem based on Chapit method. Here in the question, find the complete integral of the partial differential equation. Equation is given by p square plus q square minus of 2px and minus of 2qy plus 2xy is equal to 0. Let's problem. Given equation is f of x, y, z p q is equal to p square plus q square minus of 2px and minus of 2qy plus 2xy is equal to 0. We have to solve the given problem with the help of Chapit method. First, using Chapit method to solve the given problem. We can write Chapit auxiliary equation. Chapit auxiliary equation is given by dp upon del f upon del x plus p and del f upon del z is equal to dq is del f upon del y plus of q del f upon del z, and for dz minus of p del f upon del p and minus of q del f upon del q. For dx minus del f upon del p, and for dy minus of del f upon del q. We must remember the following Chapit auxiliary equation to further proceed the problem. We have to find the del f upon del x plus p and del f upon del z. Then we have to find del f upon del y plus of q del f upon del z. Then further we have to find minus of p del f upon del p and minus of q del f upon del q, and also find minus del f upon del p and minus of del f upon del q. And we have to put in the Chapit auxiliary equation using equation 1. This is let equation 1. We have to first find del f upon del x plus p del f upon del z. Differentiating equation 1 partially with respect to x. Here is the coefficient of x is this and this. So minus of 2px is differentiating partially with respect to x, that is minus of 2p, and differentiating 2xy with respect to x, that is plus of 2y. Further we have to find del f upon del y plus of q and del f upon del z. Again differentiating equation 1 with respect to y. Here is the coefficient of y is this and this, to minus of 2qy, differentiating partially with respect to y, that is minus of 2q, and again differentiating 2xy with respect to y, that is plus of 2x. Further we have to find minus of p del f upon del p and minus of q del f upon del q. We have to find that is minus of p and del f upon del p. Equation 1 differentiating partially with respect to p, that is p square differentiating with respect to p is 2p, and there minus of 2px is differentiating with respect to p, that is minus of 2x, and then minus of q, and again differentiating question 1 with respect to q, that is q square differentiating with respect to q is 2q, and from here minus of 2qy differentiating partially with respect to q, that is minus of y, minus of 2y, and from here we can also write that is nothing to change. Further we have to find del f upon del p, minus del f upon del p. Equation 1 differentiating partially with respect to p, that is p square differentiating with respect to p is 2p, and minus of 2px differentiating partially with respect to p is minus of 2x, and further we have to find minus del f upon del q, minus del f upon del q. Again equation 1 differentiating with respect to q, here q square partially differentiating with respect to q, that is 2q, and minus of 2qy differentiating partially with respect to q is minus of 2y. Further we have to put the value in the Chapit auxiliary equation. First we have to put minus, once again, del f upon del q. Here is minus is already present, so this is minus, and from del f upon del p is also minus present, that is, one second, we have to put first minus del f upon del q. We have to put the value of del f upon del q, one second. We have to put the value of minus of del f upon del q, that is minus of 2q minus of 2y. Further we have to put minus del f upon del p, that is minus del f upon del p is given by minus of 2p minus 2x. Further in the dz for minus of p del f upon del p and minus of q del f upon del z, we have to put the value, that is here is minus of p and 2p minus 2x, and minus of q 2q minus 2y, 2q minus 2y. Further we have to put the value of del f upon del y plus of q and del f upon del z. This is the value minus of 2q plus of 2x, and then we have to put the value of del f upon del x plus p del f upon del z, that is minus of 2p plus 2y. Further we have to solve. Further we have to solve, taking this is the first, this is second, and this is third, and this is fourth, this is fifth. Taking first and second is equal to taking fourth and fifth. From here taking first and second, that is dp plus dq upon, here is minus of 2p plus 2y, and for dq minus of 2q and plus of 2x is equal to, for fourth and fifth, that is dx plus dy upon minus of 2p and plus of 2x, and from here is minus of 2q and plus of 2y. From here is minus of 2p and plus of 2y, that is minus of 2p plus of 2y and minus of 2q and plus of 2x. Here from this is cancel out, then the remaining is dp plus dq is equal to dx plus dy. On integration both the sides, that is on integration of dp is p and integration of dq is q is equal to integration of dx is x and integration of dy is y, and taking constant as a. From here we have to write, that is x is taken into left hand side, that is p minus of x plus, and y is also taken into left hand side, that is q minus of y is equal to a. Let this is equation 2. Further we have to equation 1 can be also written as, that is p square plus q square minus of 2px and minus of 2qy and plus of 2xy, and we can also add something, that is plus of x square and minus of x square and plus of y square and minus of y square. This is nothing to change, we have to modify the equation 1. We can take p square and plus of x square and minus of 2px, and from here that is plus of q square and plus of y square minus of 2qy, and from here then the remaining is once again minus of x square and minus of y square, and from here is plus of 2xy is equal to 0. We have to arrange the above equation, and we can write p square plus x square minus 2px as a p minus x ka whole square, that is on opening p minus x ka whole square, that is p square plus x square minus of 2px, and we can also write q square plus y square minus 2qy as a q minus y ka whole square, and from here taking minus common, that is x square plus of y square and minus of 2xy is equal to 0. From here that is p minus x ka whole square plus of q minus y ka whole square and minus of x square plus y square minus 2xy is taken into right hand side, that is plus of x square plus y square minus of 2xy, and we can also write that is x minus y ka whole square. Let this is the equation 3rd, and from using the following identity we must remember, that is a plus b ka whole square plus of a minus b ka whole square is equal to 2 times of a square plus b square. We must remember this identity to solve the following problem. A plus b का whole square plus of a minus b का whole square is equal to 2 times of a square plus b square. From here let that is p minus x as a, let's suppose p minus x as a and q minus y as a b. Let's expand into the formula, that is first we have to write a plus b, that is p minus x and plus of q minus y का whole square, that is a square a plus b का whole square plus of p minus x and minus of q minus y का whole square is equal to 2 times of p minus x and plus of once again p minus x का square plus q minus y का square. We have to write here, let's suppose p minus x taken as a and q minus y is taken as a b. We have to expand, that is a plus b का square plus of a minus b का square is equal to 2 times of a square plus b square. Further we have to put the value in the above relation, that is p minus x and plus of q minus y is written as a. From equation 2 we can put here, that is a square plus, and from here p minus x and minus of q minus y, once again p minus x a square plus b square, a square and once again we can also write p minus x का whole square, and we can also put, that is p minus of x and minus of q minus of y का whole square is equal to 2 times of, from here that is p minus x का whole square plus of q minus y का whole square. From equation third we have to put the value, that is p minus x का whole square plus of q minus y का whole square is equal to x minus y का whole square, that is 2 times of x minus y का whole square. Further we have to proceed. Further we have to also write, that is p minus x minus of q minus of y का square is equal to 2 times of x minus y का whole square, and a square is taken into right hand side, that is minus of a square, and from here p minus of x and minus of q minus of y is equal to under root of 2 times of x minus y का whole square minus of a square. And from here we have to find the value of p and q from here, that is p minus of x and minus of q and plus of y is equal to root 2 times of x minus y का whole square minus of a square, and we have to find the value of p, then p minus x minus of q. One second. P minus of x, a plus b का whole square and a minus b का whole square is equal to 2 times of a square plus b square. From here we have to find the value of p first. That p is equal to root 2 times of x minus y का square minus of a square and minus of x minus of q and plus of y taken into right hand side, that is plus of x and plus of q and minus of y. And from here we have to also find the value of q, that is q is taken into right hand side, that is q is equal to p minus of x plus of y and minus of root 2 x minus y का whole square minus of a square. We have to put the value in the following identities, that is dz is equal to p dx plus q dy. Putting here, that is dz is equal to p dx, the value of p is here, that is under root of 2 times of x minus y का whole square minus of a square dx, once again plus of x and plus of q minus of y whole dx, and plus of, in place of q we have to put, that is p minus of x plus of y and minus of under root 2 times of x minus y का whole square minus a square and whole dy. dz p dx is equal to q dy. Further we have to solve solving the following, that is we can also rough this part. That is dz is equal to under root of 2x minus y का whole square minus of a square dx and plus of x dx and plus of q dx and minus of y dx. Further we have to open second bracket, that is plus of p dy and minus of x dy and plus of y dy and minus of root 2 times of x minus y का whole square minus of a square dy. We have to solve the following. Arranging first, that is dz is equal to, from this part to this part we have to take a common root 2 times of x minus y का whole square minus of a square, taking common, that is dx is here and here is minus of dy. Further we have to take x dx and y dy in one bracket, that is plus of, one second, x dx plus of y dy, and the remaining is q dx and, one second, we have to take common from x dx y dy, and the remaining is y q dx y dx. This part is, one second, we have to take common dx. We have to take common dx from here, that is plus of q minus of y dx and plus of p dy. Further we have to solve, one second. Further we have to solve, you can also write root 2 times of x minus y ka whole square minus of a square, and dx minus dy is also written as dx minus y, and plus of x dx and plus of y dy, and we can also remaining as it is written as, that is q dx and minus of y dx and plus of p dy. From here we have to take x minus y as a t, that is x minus y as a t. From here, that is dx is equal to dt. We have to put here, that is under root of 2 in place of x minus y, we have to put t, that is 2t square minus of a square and dx minus y in place of, we have to write dt plus of x dx plus of y dy and plus of q dx and minus of y dx and plus of p dy. On integration both the sides, that is on integration of dz is z, and using the formula, that is from here, and we are aware of this formula, that is under root of, we can also write a square minus x square minus of, one second, something is missing from the